Very good morning. Today we will discuss probability error calculations. For time being, I already derived this equation. Now, once I will explain. Now, see the probability error calculation. So, what is the need to here to calculate probability error? We seen yesterday. See here, for bit 1 is transmitted, that is 0 to TB period 5 volts. If it is affected by the noise, there is a small voltage, small noise, there is a no problem. See here, it is the deterministic signal, but when it is affected by the noise, so this noise signal is a random signals. So to find the error in the random signals, the tool is probability error, right? Okay, if the same signal will be affected by more noise, the signal becomes here. So if we send bit 1, we received bit 0, right? So to find the error in random variables, we have to use probability error tool, right? Now I am going to calculate probability error calculation. We know that the Gaussian density function consisting of two parameters, one is mean, another parameter is a standard deviation. This is also called as under root variance, right? The standard deviation is also called as under root variance. Now the Gaussian function will be represented a random variable x and taken the value small x. So the random variable, the Gaussian function f(x(x) is equal to 1 by under root 2 pi sigma square e power minus x minus mu whole square by 2 sigma square. Sigma square is a variance and mu is a mean. Now the probability distribution function f(x(x) is equal to integral minus infinity to x f of x dx. This is the Gaussian function. Probability distribution function f(x(x) is equal to, this is the equation of probability density function or distribution function of Gaussian function. So this can be represented where we know the f(x(x) value, that is this one. By substituting that one here, this is a minus infinity. Okay. Now that is minus infinity infinity 1 by under root 2 pi sigma square e power minus x minus mu whole square to sigma square, right? Now see here, I am applying for mu, that is mean is equal to 0 and variance is equal to 1, the Gaussian function becomes like this one. So here the middle part mu is 0 and this is my variance is 1. My probability distribution function f(x(x) is equal to becomes this. Now I want to compare this function with a q function. Here the q function is a function that is represented, q function q of y is equal to integral y to infinity 1 by under root 2 pi e power minus s e power minus y square by 2 dy, where q of minus y is equal to 1 minus q of y. This is a q function, mathematical equation of q function. Now see here, we know the block diagram of matched filter. In the last class we discussed, this is signal Si of t, that is either bit 1 or bit 0, and this signal is affected by the noise. This is white Gaussian noise, and output of this summer is R of t, and filter, this is my matched filter H of t, output of filter is Y of t. So the filter Y of t is passed through a sampler for every TB duration, that is t is equal to TB, so that it becomes Y of TB. So Y of TB, this DC signal is passing through threshold comparator. This threshold comparator, it consists internal threshold voltage. It compares the sample with internal threshold voltage and produces output. Right, Si of t, Si of t is, that is bit 1 or bit 0. Let us take S1 of t for bit 1, S2 of t is bit 0 for 0 to TB duration. Now R of t is a sum of Si of t and Ni of t, N of t. Now filter here Y of t is equal to R of t convolved with the filter H of t. Y of t is equal to, just by substituting here R of t value, this R of t value, it becomes Si of t plus Ni of t is convolved with Hi of t. Now Si of t is convolved with H of t plus N of t convolved with H of t. So this is signal component and this is noise component. Here I am assuming the output Y of t, instead of, too simple to understand, Z of t, output of the filter Z of t is equal to Ai of t, I am called it as signal component, plus N naught of t, called it as noise component. Right, see here, when Si of t is passing through filter, we will get signal, we can passing through filter, we will get signal component. Noise, we can passing through filter, we will get noise component. Let see here, let 1 will be the bit 1 or symbol 1 is transmitted. The Z is filter output, Z is equal to, signal component is A1, noise component is N0. Mean of this output filter, mean of this filter Z is written as expectation of Z. Expectation of Z is equal to expectation of A1 plus expectation of N0. Expectation of Z is equal to expectation of A1 plus expectation of N0. So we know that expectation of noise is always 0. So the output of the signal component, right, E of Z is equal to expectation of A1, that is expectation of A1 will be A1. So this is the signal 1 transmitted, that is represented by the probability density function Fz by 1, where the mean is A1 with y-axis Z. Now the equation of probability distribution function for transmission of bit 1, that is represented by Fz by 1 is equal to 1 by under root 2 pi sigma square e power, here Z is the output of the filter minus A1 is the mean by 2 into sigma square. This is the first equation for bit 1 transmitted. Now if you see the bit 0 transmission, let see here the same concept here. Now let bit 0 is transmitted, bit 0 is transmitted. Similarly, the filter output Z is equal to A2 plus A0, N0. For bit 0, A2 is a signal component, N0 is a noise component. Similarly, here also I want to find mean of E of Z is equal to expectation of this entire term. So expectation of Z is equal to expectation of A2 plus expectation of N0. We know that noise component again 0. So expectation of Z is equal to expectation of A2, that is equal to A2. So this is the probability distribution function for 0 transmitted, that is represented in y-axis f Z by Z0. For x-axis Z, the mean is A2. Right? The equation of Z filter output, that the probability distribution function f Z by 0 is equal to 1 by under root 2 by 2 pi sigma square and e power z minus a2 by 2 sigma square. Now if you see the equiprobable, the probability of bit 1 is equal to probability of bit 2. This is the probability distribution function of 0 bit 0. This is the probability distribution function of bit 1. Here its mean is A1, for bit 0 mean is A2. The threshold voltage, the threshold level is the average level of these two. That is equal to average A1 plus A2 by 2. This is my threshold voltage. Now, if you see the probability error, bit error, for example, if I want to transmit bit 1, I want to transmit symbol 1 or bit 1, if I received bit 0 as output, it is called bit error. Yes or no? For example, if I want to transmit bit 1, at the output of the threshold level, if I received bit 0, this is called bit error. So here I want to find the probability of bit 1. So the probability error of bit 1 will be represented integral minus infinity to Vth by f of z by 1 dz. Vth is a threshold voltage. See here, for bit 1, here I am transmitting bit 1, instead of bit 1, I am received bit 0. Bit 0 means the bit 0 will, it is from minus infinity to up to V threshold voltage. Yes or no? Instead of 1, I received this bit 0. So for finding probability error, that is from minus infinity to V threshold is my limits, minus infinity to V threshold, right? For bit 1, I am transmitted bit 1. This is my bit 1. F of probability density of my bit 1, this is this one. And I received here bit 0 instead of 1. Similarly, if I transmit bit 0, right, I received symbol 1 at the threshold level. So this is called as a bit error. So here also I want to find the probability error for 0. So here I am transmitted bit 0, instead of bit 0 I received bit 1, so that my limits becomes V threshold to infinite. So here my limits of probability error of 0 is V threshold to infinite, and bit 0, that is f of z by, this is Gaussian function of bit 0, f of z by 0 dz, right? Now see here, now I want to take any one, either probability of error 1 and probability of error 0, I can find the probability of error. Now for time being, just I want to take only, I will derive only one, that is probability of error calculation, probability of error for 0, right? The probability of error 0, the limits are V threshold to infinite, f of z by z naught and dz, right? Now see here, so V threshold value is the average value, that is a1 plus a2 by 2 to infinite, and 1 by under root 2 pi sigma square and e power, the same equation I am written here as f of z by z naught equation, just I am written this one, into dz, right? Now let this value I am call it as y is equal to z minus a2 by sigma, so that the differentiation of y, dy is equal to dz by sigma, so dz is equal to sigma into dy. Limits becomes, so here I want to substitute the limits here. So the first limit is a1 plus a2 by 2. So by putting z is equal to a1 plus a2 by 2 in this equation, so y is equal to, limit y is equal to, by putting z value in y, so this z minus a2, z is equal to a1 plus a2 by 2 minus a2 pi sigma. So by doing here, y is equal to a1 minus a2 by 2 sigma, right? Now probability error of 0, just putting here this value, this is becomes, this is my y, right? Y is equal to a1 minus a2 by 2 sigma to infinite. The same equation I am written here, the same equation I am written here, right? And dz is equal to sigma into dy, so sigma into dy, and here y is equal to z minus a2 by sigma. So just I am substituting all the values in above equation, the equation becomes like this. So here the sigma, this sigma square is cancelled. So finally the probability error of 0 becomes 1 by 2 under root 2 pi, and this is a1 minus a2 by 2 sigma infinite integral e power minus y square by 2 dy. So this value is y. So now I want to compare this equation with Q function. Q function is also same as this equation. So 1 by 2 pi under root 2 pi, and integral, this value we can call it as y already, y to infinity, and it is also e power minus y square by 2 dy. So here also is e power minus y square by 2 into dy. So this entire function is same as Q function. So here my probability error 0 is equal to Q function of q of y, right? What is the y value? Y value is a1 minus a2 by 2 sigma, Q function of y. So this is a1 minus a2 by 2 sigma. So if I write this one into the root, so it becomes a1 minus a2 whole square by 4 sigma square. So this one we can call it as difference signal power. Yes or no? Yes or no? This is for signal 1, bit 1, this is for signal 0, bit 0. So Q function of under root, this is called as a signal power. This sigma square we know that is called as a noise power into 4. Right? The Q function is equal to under root difference, this is called different signal power by noise power. Sigma square is a noise power by 4 into 4. Right? Now if you see here, the equation becomes same equation. Once again I am written here, probability error is equal to Q function of difference signal power by noise power. We know that yesterday we are calculated signal to noise ratio is equal to 2 into Es by N naught, right? S by N is equal to 2 into Es by N naught. Just I am substituting this signal power by noise power, So here signal to noise ratio, that is 2 Es by N naught, here 4. So 2 2s are 4. So the probability error equation is equal to Q function of S difference signal by 2 N naught. And another one, the Q function properties, when Q of y is equal to, where this internal value y increases, the Q function value is decreases, and when y increases, the probability error automatically decreases. Because of Q of y is decreases, probability error is decreases. Here in this equation, the E of S, we know that E of S, this energy of the signal for every TB duration, energy of the signal every TB duration, that is 0 less than ST less than or equal to TB. For this TB duration, that is for bit 1, this is bit 1 and bit 0. So energy of in between 0 to TB, that is represented ES is equal to S1 of t minus S2 of t whole square into dt. Yes or no? We know that energy equation. So energy equation is equal to, simply represented for the limits here for 0 to TB, whatever the function, square into dt. So this is energy signal, and the probability error equation is this one. Okay, I hope you will clear the operation of probability error calculation. Tomorrow we will find probability error of ASK, FSK, QPSK, SPSK, right? Now today assignment is derive the expression of probability error. So this derivation is very important for JNTU examination. Thank you.